So let's start. Let me know when my screen becomes visible. Okay, so this is the first problem of today's step 3, and in this problem we're given that the price of one yogurt at okay, please don't endnote. Like I don't know how many times I have to tell this, but now I have disabled it. But like, please keep this in mind for the future sessions also, that you are here to learn something, like not to experiment. I know like whoever did this, he was like, they were just trying to experiment, but still, like this just wastes the time, like the precious time that we can have for our discussion. So in this problem, we're given that the price of one yogurt at Boss, whatever this is, store is A bulls, and there is also a promotion that way you buy 2 bulls, and like where you buy 2 yogurts for B bulls. Now Maxim needs to buy exactly n yogurts, and when buying 2 yogurts, he can choose to buy them at a regular price or at a promotional price. So we need to find what is the minimum amount of bulls Maxim should spend to buy n yogurts. Okay, by the way, I'll discuss till problem F. So now getting back to this problem. So for one, we have to pay A bulls for 1 and B for 2. So we just need to check if like whether it's ever profitable to do this or not. So when we will do this, when B is less than 2 times A, then we'll try to buy as many pairs as we can. That is precisely n by 2, and the price of these will be B. And if n turns out to be odd, that is, if this is 1, then we need to buy 1 with A. This is for this case. Otherwise, simply, if this is true, then this. Otherwise, we can simply buy everything using like these, like one at a time. So the total cost will be n into A. So this is when we are buying 1 yogurt at a time. Yes, this is first question. Any doubts in this? What about others? Okay, so let's move to the implementation. So the implementation is very simple. Just take n, A, and B as input. Just check that B is less than twice of A. Because if B is not less than twice of A, then you can just simply buy 2 yogurts 1 by 1 instead of buying both together. So if B is less than twice of A, this is the same thing that I have initially mentioned, that divide n by 2 because you'll buy these as pairs, multiplied by B. And if this turns out to be odd, you cannot buy all the number. If you have to buy 7 yogurts, you cannot buy all of the 7 using like 7 as pairs. You'll buy 6 and then 1 is left and you'll have to buy it individually. Otherwise, if this is not true, just print n into A. So going to the next problem. In this, we are given that a progressive square of size n is an n cross n matrix, and Maxim chooses 3 integers a11, c, and d, and constructs a progressive square according to these rules. So basically, a of I plus 1, that is the element in the next row in the same column is simply this element plus c, and the element in the next column and in the same row is simply the current element plus D. So for example, if we have this is the progressive square. I'll like show you this how we get this. But the problem is that now we have n, c, and d, and we also have n square integers, and we need to find that whether it's possible to get a perfect progressive square, not perfect, but a progressive square using these n, c, and d, and that progressive square is having only these integers, n square integers. So see, we are given a progressive square is a11, then in this element could be a11 plus c. Like here we added c, here again we'll add c, so a11 plus 2c, and when we go to this side, this will be a11 plus d, and this will be a11 plus 2d. Similarly, this element can be calculated from both of these, a11 plus c plus d. This is basically, in this I'm adding d, and in this I'm adding c. So this way we can get the complete square. Now what we given? We given n square integers. We are given, let's say n was 3. If for n equals to 3, we are given these 9 values. We are given n equals to 3. We are given this d. What is the d? What is d that is being added? And what is the c that is being added? So we need to check whether it's possible for us to get like a progressive square using n, c, and d that has only these integers. So first of all, c and d are both more than 1. So more than or equals to 1. So a starting point for us will be to find the minimum value among these n square values, because these n square values are like, we are checking that these n square values are going to fit in this square or not at some positions, right? So if c and d are both more than 1, then the minimum value, which is like whatever the minimum value, it is going to be present at this place only, that is the topmost and leftmost value, top left corner. So we just need to find what is the minimum in this array, and that is definitely this a11. Yes, no? Okay. So now once we know what is a11, can we not directly like just create a progressive square? We know a11. Okay, let me explain this once more. So by definition, this is what we have. Like if we have a11, c, and d, and n, we can create a progressive square by keeping the a11 value at the leftmost corner, and then when I'm going in the same row, I'm like going to the next column, I'll add d. I added d here, then I again added d. So first time it became a11 plus d, then it instead of a11, let's say it's a only. So a, then a plus d, and then a plus 2d. And when I'm going down, it would be like I'm adding c. So this is a plus c, this is a plus 2c. This side, it would become a plus c plus d. In this, I'm adding d. In this, I'm adding c. Can someone tell me what will be here? Like in terms of a, c, and d, what will be here? Yes, a plus c plus 2d. A plus 2c plus 2d. Not 3d, but c. This should be 2d. No, no, no. This would be, I think I have a plus c and a plus d, a plus c plus d, a plus 2d, and a plus 2d, a plus c. This would be c only. And a plus c plus 2d. Yes. Why? Because here in this I would add d, and in this I would add c. So a plus c plus 2d. Here it should be a plus c 2c plus d, and here it should be A plus 2C plus 2D. So this is how these are my values. These are my values, and what I'm given 9 values. Like eventually, if I had all of these A, C, D, and N, I would have made this as the progressive square. But the thing is, I only have these, and I have these 9 values. So by default, I can look at this square, and since C and D are both more than or equals to 1, the minimum value in this square is this, right? This is the minimum value. Yes, no? Is it making sense now? Okay, so this makes sense. Now, what I have to do, I have to just find the minimum out of these 9 values, and I know that it would be here. It would come here. So now, once I know my A, I also know C, D, and N because they are given the problem statement. Can I not directly make this progressive array or this progressive square? I can, right? So if I can make this perfect progressive square, I just have to build this, and I have the 9 values. So I just need to compare that the 9 values that I get here are part of this array. So the best way to do this is I'll place these 9 values in another array. So let's call this as array B. This is your array A. Sort this array, and compare that they both are same. If they turn out to be same, yes, this array can, like this array represents the progressive square that can be made from this CDN. Otherwise, no. Is it clear? So we are just building our progressive square and then comparing. Any doubts? Okay, so let's look at the implementation. So in this, I have first taken N, C, and D as input. Then I have taken all the N square numbers in input. Then I'm finding the minimum element in array A. So this is my A11. Then this is my temporary matrix, progressive matrix that I'm forming using this minimum and the C and D's that I have. So the first value is X. I'm just filling these values. Like in the first I'm filling the first row. Like each column will have the plus D value than the previous one. And then going to the next row, I'm just adding plus C for each value. Like each value will be plus C more than the previous row value. Then all of these, like this is the progressive square that I have. I'm inserting all of these value in a new vector or an array, sort both of these and just compare that if these two are same. If these two are same, print yes, otherwise no. Yes, you don't need this. Like your computation will become a little complex, but you don't need to actually create. Any other doubts? Anything that I'm missing?
Any other approaches other than this?
Like you can, but since this is the second problem of Dev 3, and like we can just apply brute force.
So instead of sorting, we can use map.
Yes, we can use map also. Just compare the count using map. But that will also be n log n only. So like this is better. You just sort it and compare. Like
But
I
if we
would
will use unordered map, then
yes,
in
we can,
average
like,
case it is
but the thing is, like, yes, we can, of course, we can use an ordered map. But the thing is, like, it's not required here.
yes.
An ordered map will be close to not big O of 1, but like big O of 1 for one value, but you have n values. So big O of n. And it's not like completely constant. It is not like big O of 1, it has some constant factor. So, but yes, it's not required. Like you can just like these two lines will work. But make sure that you're sorting these because the order can be different in both.
Hello.
Yes.
So I have one question, like here you have compared two of the array when you have sorted it, if A equals to B. So can we compare like map also like this or other data structures?
Let's see. This is like internally it's implemented like if for those data structures also there is an internal implementation in C++ that see when I do this operator, what this operator does internally in vector, this operation is implemented at what would happen if I do plus plus, like if I do equals to, but for vector plus equals to is not implemented. These are operators, right? So this is incrementing, like the incrementation operator. There is like plus plus operator. So equals to is implemented. For set and map, I also think it's implemented. You can check once. So that's that. And if you want to check, you can just go through the documentation, and there you'll see that this is implemented for vector. That if I do this is not comparing the two things using their address. If in map, if you don't get the right answer, then you might like the two things might be getting compared with their address value. Like what is the address? A, like if A is in map, then this is a variable which is pointing to an address which is storing the starting point of the map, right? The first value of the map. So, but I think it should also work because internally they can see plus it would be implemented. What would this plus plus like this equals to operator mean? But in case for some other data structures, if it doesn't work, then it simply means that it isn't implemented.
Okay, so is it for inbuilt data structures?
Like yes, like that what I mean, but that's what I mean by that this is already implemented in C++ libraries of
Have
vector.
have you used it in like in case of other data structures except for this vector?
I don't remember. Maybe some like I think I have used it for map, but I don't clearly remember. Actually, yeah, I don't remember.
No, that's fine. So okay. Yeah, because first time I'm seeing like
Like yes, yes. Let's do one thing after the contest. Like we can just like there, it is just two lines of code. We'll write two maps. Like you can also check, just create
But
two maps and insert two like same values in both of them, and just check whether they should work similarly. Any by the way, this
but
comparison is like this is not anything like better than what you will do. Like if you compared two arrays, like how will you compare two array of vectors? You'll go through each of the values and you'll compare each index values, right? This is what you'll do. So you're basically iterating through the complete array or vector. This is same what is being done here. This is also big O of n. So don't get confused. This is not constant big O of 1. So internally, like there is no way to compare two vectors or two arrays other than iterating through both of them. So like if you're not aware of this
no.
is just a syntactical sugar. Like this just is like creating like giving us a shorter code, but this is no way better than what we would have originally done. So anything else?
No, thank you. I had no idea about it.
Oh, hello, sir.
Yes.
Sir, can you give a small description like how we can do it without creating the temp?
Like in that case, you can just create one of the rows and see, I'm not using any of the values to create a row. I'm just using the previous row, right? So just create one row and directly insert in this vector B. You don't have to create the complete progressive matrix. Understood?
Oh, yes, sir. Okay. I'll try to implement it.
It's like, see, I plus 1j is being computed from ij. So this is just the previous one. So you don't actually have to create the complete progressive matrix. Only one row would also suffice. Anything else?
No, thank you, sir.
Okay, let's see the implementation for this. Okay, this is the implementation. Let's move to the next problem. So the next problem is that n ships set out to explore the depths of the ocean. The ships are numbered from 1 to n and follow each other in ascending order. The ith ship has durability of AI, and the Kraken attacks the ships k times in specific order. First, it attacks the first of the ships, then the last of the ships, then again the first, and so on. And each attack by the Kraken reduces the durability of the ships by 1. Now, when the durability of the ships drops to 0, it sinks and is no longer subjected to attacks. So let me explain this problem. So like eventually we have to find how many ships would sunk by Kraken's attack. So see, we are given that there are some ships. Let's say these are the ships. The strength of this ship is 3. So let's say Kraken would attack, let's say 10 times. So first Kraken would attack this. The strength of this ship would decrease by 1. It would become 2. The rest, all the ships would remain same. Then Kraken would attack this, and the strength of this ship will become 4. Then Kraken would attack this, and the strength of this will become 1. Then this, and the strength will become 3. Then the next time when Kraken attacks this, the strength of this will become 0, right? So once this becomes 0, this ship sinks. And now we have 4, 1, 1, 3, and Kraken would attack this because this was the first, this is the last. So first ship has been attacked, now the last. So how many attacks have been done? First attack, second, third. This was the fourth attack, fifth attack. After fifth attack, this became 0, and this is the sixth attack, right? So sixth attack, after sixth attack, this will become 2. Then seventh attack would be on this ship because this is the first ship now. So this will become 3, and so on, like you see, right? And eventually we need to find how many ships will sink. Is the problem statement clear? Yes, no? Now, the thing is, can we consider minimum of first and last? Not directly. Because the ships, like let's say Kraken would attack 10 times, you have 7, 1, 2, 3, 7. You cannot directly say that what is the minimum of these. Let's say 7 and 6 was there. Let's say this is the minimum. You cannot directly say that the Kraken would be able to sunk this. Why? Because Kraken is not directly attacking the first or last ship. They are like the Kraken is attacking one by one. So one attack here, another attack here, another attack here, then here. So like this. So I don't think like in this scenario, in 10 attacks, Kraken would be able to sunk this, because if you need to have 6 attacks here, you need to have 6 attacks here also. You can check first attack, second attack, third, fourth, fifth, sixth. You can see, right? If there are 3 attacks here, 3 attacks here. So if you need 6 attacks on this side, on the last ship, you need 6 attacks on the first ship. And this total is 12. So you cannot directly take the minimum of these and say that it will sunk. You have to do one by one. But the thing is, if you do this one by one, it will give you TLE, because K is in order of 10 to the power 15. So now we need to come up with a smart way. First of all, is the problem statement clear now? Okay. So now, instead of directly taking what is the minimum, if we, let's say we have these values, and I know that Kraken would attack this first ship. So can I not do one thing? First of all, let's say this value is X, this value is Y. Let's say Z is minimum of these two. Okay. Now, if let's say the minimum was x, if x is the minimum, that means x is equals to z, then I just like the first attack would be here, second would be here, then again attack on this, attack on this. So x would sunk first. Out of x and y, x will sunk first. And how many attacks are required? Total number of attacks to like before this is sunk is there would be x attacks on this and x minus 1 attacks on this. So total 2x minus 1. Like for Kraken, after 2x minus 1 attacks, this ship would sunk. Is this thing making sense? Yes, no.
Yes, sir.
Okay, so we just need to do one thing. Just subtract k, like from k, just subtract this value. This ship is sunk, remove this. And by the way, can someone tell me, will like the ship that after 2x minus 1, which either like will it be the first or the last that Kraken will attack after 2x minus 1
Last.
attacks?
Last.
Because 2x like after 2x attacks, it would be here. After 2x minus 1 attacks, the last ship that was attacked is this. That's why this got sunk. So technically, after 2x minus 1 attack, that is the 2x attack. This is the target ship. So then we can just continue for this. So this is the case when x is the minimum. Now what happens if y is the minimum? And this is for if first ship is being attacked. So if y is the minimum of x and y, then how many attacks are required to like in that case y will be the first one to sunk. Yes, in that case 2x attacks are 2y, not 2x, 2y. 2y attacks are required, right? Because y attacks are required for this and y attacks will be done on this also. So just subtract 2y and increase your answer by 1 and remove this from your like ships list. And now can someone tell me after this which ship will be attacked, first or last? After like at the time when this ship sunk, first, because this was the last and this got attacked, so first. And you have to do the same thing when if the last ship is being attacked. If the last ship is being attacked, then again if x is the minimum, you have to do whatever was being done here. If x is the minimum, do whatever was being done here, and if y is the minimum, then do the same thing which is being done here. Basically, these are the ships. Kraken is attacking this thing. Y is the minimum, so do the same thing. Just subtract. If like first of all, just like check if you can have 2y minus 1 attacks or not. If 2y minus 1, if k is less than this, then simply like no ship will sunk. Otherwise, subtract k minus, like from k, subtract this 2y minus 1 and remove the last. Otherwise, from k, subtract 2x. Okay, which part is not clear? This part? Okay, let me explain this part again. So, see, in this part, the first ship was being attacked. In this part, the last ship is under attack. So, if let's say currently we have some ships and the last ship is under attack, we'll do the same thing. The first ship is having x strength, the last ship is having y strength. If x is the minimum, then out of these, currently this ship is under attack. This is x, this is y, this is less. So first this will sunk. So for this to sunk, it should get x attacks and this should also get x attacks. Right? First attack this, then this, then this, then this. So x and x, so 2x attacks. Same thing is here. If y is the minimum, then you just need x attacks on this side and x minus 1 attacks on this. Like y attacks on this side and y minus 1 attacks on this side. Like the same thing, but I have just reversed it. So is it clear? Now we are just checking while our k is more than 0 and our number of ships are more than 0, the number of ships. So while this is true, we'll keep doing this, and this is big O, like we can just, this is just if else condition. So finally, once one of these conditions becomes false, we can print our answer. Either our K will become 0, that the Kraken cannot attack, or the number of there are there are no ships left. Yes, I'll show you the code. Just give me a second. So see, first I have taken N and K as input. Then I have used a DQ. Why a DQ? Because DQ is the best data structure that can be like used in problems like this, because I have to insert and I have to remove values from both front, like that is the first place and the last place. So what I have done, I have inserted first of all the values in my DQ. This PB is pushed back. So just inserting one of each value one by one in my DQ. Then initially, let's say my F is nothing but I don't think I have used this F. So starting from answer 0, what I have done, okay, I have used this F. F basically if F is 1, it means that the first ship is being attacked. If F is 0, it means that the last ship is under attack. Now, while my K is more than 0, that is Kraken can attack, and while there are some ships, I'm first checking if there is just one ship. If there is just one ship, like there are not two separate X and Y's, you just have one. So just check whether the strength of the ship is less than K. If it is, increase your answer by 1. And in any case, since this is the only one ship, even if it was more, just there is no point checking this loop again, just to break it. Now, otherwise, if there are 2 or more ships, first, this is the strength of the first ship, this is the strength of the last ship. PPF is pop front, this is pop back. So just remove the first ship and the last ship. This is the minimum of X and Y. Now, the case when the first ship is under attack. If the first ship is under attack and the minimum value, this is the minimum value is X. First of all, check if Kraken can attack this much. So instead of Z, I should have written X, but you get it, right? Z is equals to X. So if K is less than this much, then the first ship cannot sink. So just break your loop. Otherwise, the first ship can sink, decrease, like K, how many times the Kraken would have attacked? These many times. How many times the last ship strength will decrease? How many times the last ship will get the attack? Z minus 1 times, basically X minus 1 times. F is 0. Why? Now the last ship is getting attacked. In the next attack, the next attack will be on the last ship. And since I had removed both front and last ships, I'm inserting the last ship back in my ship order, that is DQ, and increasing my answer by 1. So this was the case when the first ship was getting attacked and the ship which was having the minimum strength out of first and last was the first one. This is for the case when it is the last ship which is having the minimum strength, and the first ship is getting attacked. So checking the same thing, that if this many times Kraken would attack, then this would happen. Otherwise, I'll break and just decrease the number of attacks by this, decrease the strength of the first ship by this much, insert the first ship, PFS, push front, insert the first ship in the ship order and increase your answer by 1. And the same reverse of this is done when the last ship was under attack. This else is basically if else means F is 0. So basically the last ship is under attack. Simple if else conditions, and finally printing the answer.
Hello, sir.
Yes, yes.
So why are you decreasing the strength of other ship that is
Because
not?
yes, because see, if there are these, let's say these are the ships, this is X, this is Y. This ship is currently under attack, and X is minimum of X and Y. So how many times this ship needs to be attacked to sunk this? X times, right?
Yes.
But if you attack this ship X times, how many times this ship is getting attacked? X minus 1. because once attacking this, then attacking this, then attacking this, then attacking this. So this ship gets sunk in X. You need to decrease this Y by this value, X minus 1. And these are your remaining number of ships and their strength. Is it clear now?
Yes, sir. Yes, sir.
This
It's
is
clear.
this thing. Any other doubt?
Sir,
Yes.
we can also solve it without using a DQ by placing a one pointer I at the 0th index
Yes.
and other
Yes, that
pointer
can also
J
be
at the
done.
last index.
Yes, you I and J, and basically
Then
then
decrease or increase
yes.
the I or J according to conditions.
Yes, yes. Using that thing also it can be done. Any other doubts? Okay, so let's go to the next problem. So in the next problem, we're given that Maxim has a array A of n integers and an array B of m integers, and Maxim considers an array C of length m to be good if the elements of the array C can be rearranged in such a way that at least k of them match the elements of array B. So this is the example. I'll take this example. Let's say I'll take this example here. So B is 1, 2, and 3, 4. So if k is 3, then the good arrays are 4, 1, 2, 3, and 2, 3, 4, 5. So why is this good? Because I can rearrange this as 1, 2, 3, and 4. There are at least 4 places in which these two are same. And this I can arrange as, in this also there are at least 3 places in which these two are same. So again, a good. So what we have to do, we are given an array A of size n, and we are given an array B of size m. Now it's guaranteed that m is less than equals to n. And what we have to do, for every m-sized subarray of this, we need to check whether that subarray, like if we consider this as the array, this is a good array or not for this array B. Basically, if we rearrange this, there would be at least k places that are same as in this array B. Is it clear? Is the problem statement clear, first of all?
Sir,
Yes, yes.
does subsegment or subarray means the same thing?
Yes, subsegment and subarray means the same thing. Anything else?
Sir, your notepad
Yes.
is not visible. I think you are writing on notepad.
Yes.
Are you writing on notepad?
No,
Because
no,
it's
I'm like waiting for any questions. If you have any questions, like you can ask me. Is the problem statement clear?
Yes, sir.
Okay, okay. So now how to solve this? Like we have to count all the subarrays of size m such that they are good for this array B. Basically meaning that we can rearrange the values in those subarrays and there would be at least k places which have the same values at same places as B. So how to do this? See, let's forget about the complete array A. Let's say array A is this big and array A B is this much. So let's consider this only. Like let's consider this only, these 4. And how would have you solved if you had this these four, like this M size array and this M
Sorry,
size
but
array.
are you writing right now?
Okay, yes.
But your screen is not visible. Yeah, it is visible now.
Sorry. So I was saying that let's forget about, like, let's say there is an array A. Array A is like this. There's a n-sized array A, and there is another. This is the array B, and in this we need to find how many times, like how many subarrays of size M in this array A are good. But let's forget about this complete array A. Let's say this is what we have. This is the array, this is one array, and this is another array. How would you have solved this problem then? If you had these two, let's say you have this 4, 1, 2, 3 and 5, 3, 1, 2. How would you have checked whether or not, let's say K is 3? How would have you checked? Can anyone tell me that? Like,
So we can store the frequency of each element of B in the array.
yes, perfect. Like you're gonna directly compare these. Like if you're thinking of comparison would work. Either like maybe sorting can work, but again, like complicating. The best way here is to store the frequencies in map. So 4 occurs once, 1 occurs once, 2 occurs twice, once, 3 occurs once. Just check, is 5 occurring anytime? No. 3 is occurring once? Yes, 3 is occurring once. So this can be handled. Like 1 can also be handled, 1 occurs once and 2 also occurs once. So this can also be handled. So how many elements can be handled? How can you, or you can say that how many elements can be mapped, like with some element in above array. So there are 3, at least 3 can be done. So this thing is more than or equals to K, then yes, otherwise no. Is it making sense? So this is what we would have done if the size was this thing. Just find the count in this and count in this. Let's say this is count B, this is count A. First find count A, then find count B, and just iterate over this count B. In count B, you would have two things, the element and the count. So for each element in count B, you just need to do if count, like how many elements would be overmapping. So let's say overlapping elements, like overlapping, like how many elements can be mapped. These mapped elements can be, these map elements would be, can someone tell me what is this? It is the minimum of, you need to add plus minimum of count, how many times this element occurred in array A, or in array B, minimum of these, right? If let's say that you have 5, 5, 5, 2, 2, 2, and you have 4, 3, 5, 5, 2, 2. So how many times 4 can be mapped? None. How many times 3 can be mapped? None. How many times 5 can map? Twice, because 2 is, we have 2 twice here and we have 3 times here. How many times 2 can be mapped? Twice. We have 2 times here, 3 times here. So for each element, just how many times, how many total number of elements can be mapped in both of these array, like they can be placed in at the same positions, is just sum of the number of times they occur in, like the minimum number of times they are occurring in both of these. And finally, if this mapped element, like the number of mapped elements is less than K, then we don't have a good array. Otherwise, if it is more than or equals to K, then we have a good array. And this is not a good array. Is it clear? Like this is when we had just 2 arrays of same size. Is it making sense? How would we solve this problem? Yes, no.
Yes, sir.
Okay. Now tell me one thing. Just let's say this is what we have solved the problem now. And now I want to include this value and remove this value and include this value. So what should I do? I should remove this from, like, I should decrease my count. Let's say this is A1 or AI and this is my AJ. So what should I do? First of all, from count A, I should decrease this thing and I should add and count A this thing. Count of A of AJ plus plus, right? Basically, I'm increasing the count of this and I'm decreasing the count of this. And when I'm decreasing the count of this, I just need to check that if my count B for the same value is now more than whatever the count A for this value is, then my total number of mapped elements will decrease by 1. Otherwise, it won't change, because whatever B, like number of times this element occurred in array B, count A is still more or equal of this value. So all the elements can be mapped, right? This is making sense. If this turns out to be more, then decrease mapped number of elements. And for this thing also similarly, if this is increased, just check one thing, that what will you check for this? Can someone tell me what should be the check? If count A, like the number of times in array A, this AJ occurred is less than or equals to. Why? Because you're still getting some element which earlier was not mapped, like B had more count than A. Once this becomes more, then this simply means that all the elements of this AJ, like AJ in B, are mapped. So you don't have to map. You're getting an extra element like this. In this case, you get an extra 2 here, maybe some 2 here. You get you remove this 5 and you get an extra 2. But all the 2s have already been mapped. So that's why if this turns out to be less only, then you can increase your mapped element by 1. And after each, you remove this, include this, remove this, include this, remove this, include this. So you are checking for each and every subarray of size M, and for each, just check that your mapped elements are, if more than or equals to K, increase your answer by 1. Is it making sense? Like just what we did for the first M size subarray, and continue it for each and every subarray. Just by, you have to remove one element and include one element.
Can you explain the
last-
conditions one more time?
Yes. The last check is
With an example, probably. Yeah.
yes. So when you are including this AJ and you increase the count of this in array, like for first map.
Sir,
that
can you
is-
please do a dry run on some sample test case?
Yes. I'll do it after this. So we have included this AJ, like we have increased this AJ count for map that is count A. And now we are just checking that if this was less than or equals to, like the count of AJ in the first map, that is for array A map, is less than or equals to this, then there is some element in B which is still getting mapped. So that's why we are increasing our mapped elements by 1. Now let's see this using dry run. So let's take a big test case. Let's see this. So first, forget about the rest of the elements. Let's look at these arrays. So what is count of A? So 9 occurs twice, 2 occurs twice, 10 occurs once. What about this? This is for A, this is for B. 6 occurs once, 9 occurs once, 7 occurs once, 8 occurs once, 10 occurs once. So in this, 6 cannot be mapped, 9 cannot be mapped, 9 can be mapped, and minimum of these two once. 9 can be mapped once, 7 cannot be mapped, 8 cannot be mapped, 10 can be mapped once. So K for this problem is 3. So only like for this, only 2 elements can be mapped. So this is not a good. Now I'll remove this element and include this 9. So 1 9 removed, another 9 included, is still the same thing. Now let's remove this 9 also and include this 7. So 9's value is now 1 and 7 is now 1. So 9 is still like this is 1 and 7 can also be mapped once now. So 3 elements can be mapped. So this is your 1 subarray. Now let's go further. Remove this 2. So 2, the count of 2 is 1 and now you have a 6 also. So if you have a 6, this can also be mapped. Now 4 elements can be mapped, you just needed 3. So another subarray. Remove this 2 and include 3. Remove this 2, you don't have 2, but you have a 3. So 2 cannot be mapped, 3. Still 4 elements are getting mapped. That is 6, 9, 7, and 10. These elements can be still mapped if you rearrange them, like in this subarray. So you have another subarray. That is good. Same thing again. Go ahead and do it for this. So 9, 7, 6, 3. Remove 10. You don't have a 10. You have a 6 twice. 3 is once and 6 is twice. So this doesn't affect anything. 10 is now 10 cannot be mapped because minimum of these two, like how many times it occurs in array A and array B. So this is 0. You have 3 can be mapped. So again, you get a good. Now you need to remove 9 and include 3. So 9 is removed and 3 is twice. If 9 is removed, this will become 0. 3 is not in this. So basically only 2 elements can be mapped. This is not a good. So your answer is 4. So you see, I'm just removing this, including this. And this is what I'm doing for every subarray, like when I'm going ahead. And just checking how many elements can be mapped. Is it making sense now? And out of the elements that can be mapped, if that number is more than or equals to k, I'm adding 1 in my answer. So 1, 1, 1, 1 is now 4. Is it clear? What about others?
Yes, sir.
Okay, so let me show you the implementation. The complexity will be n log n. So first I'm taking n, m, and k as input. Then I'm taking both the arrays and input. Now for the first subarray in array A of size m, I'm calculating the count A. And for complete array B, I'm calculating count B. Initially, my answer is 0. That is the number of good subarrays. And C is nothing but the number of elements that can be mapped. So I'm iterating through my count B, that is array, like the map or the frequency of elements in array B. This is the frequency, like how many times E occurs. I don't want this. I just want E. And C is how many times the numbers E can be mapped is minimum of this and this. Instead of count B, I could have just used this value also. Like this is the same thing. Then I'm just adding, like this is for the first subarray, right? So for the first subarray, I'm just checking if this C, that is the number of elements that can be mapped, if this is more than or equals to K, then I have a good subarray. So I'm adding 1 to my answer. Otherwise, I'm starting from this position, that is just after the first subarray, this position. So this is size m, and this basically including this, removing this, including this, removing this, including this, removing this. So this is what I'm doing afterwards. Just remove this. If the number of times the value that like this ai minus m in B is now more than this, you need to decrease your C, because earlier this value was getting used, but whatever was in array A, this was getting mapped to some place. So you need to decrease your C by 1. And when I'm including AI, I'm including AI. So I'm just checking that if this value is still less than count of AI, like in array A, the value is less than or equals to this thing, the number of times it is in array B, I'm incrementing my mapped values. And for every subarray, I'm just adding 1 to my answer. The number of mapped values is more than or equals to k. Finally, I can print my answer. Is it clear?
Well, sir, can you share these codes of
Yes. Like
problems?
you'll get each and every code. Don't worry about it. You don't have to take screenshots. You don't have to do anything. You'll get the
Thank
codes. But right now, I would like, instead of like, just like get a brief idea. I know, like just looking at this, like, is if you haven't solved these problems like these earlier, and I know like
Sir, can
many
you
of you
please
are.
explain these two if condition again?
Yes, I like explain them. So if you're like, I know many of the people right now who are on the call, like you are just starting with CP. So I know like this can be overwhelming, but believe me, like what you should do, like just get a brief idea and then you should try on your own. Like even if you get confidence, like by seeing at my solution, or like when I'm explaining, you might get a sense that okay, this is easy and it could be solved. But believe me, it would be much better if you try this on your own. And when you get an AC, like your solution gets accepted, then like first of all, it's better for learning, and the second thing is like you'll be able to hold on to whatever you have like learned, or like in a much better way. So like let me explain these two conditions again. So this condition is basically I'm removing this element, right? So if I'm removing the element from like array A, like from my current subarray, so I need to check if this value was getting mapped. So if this was getting mapped, this basically means that I now have a count which is less than, like this value's count in A is less than the number of times this value is in B. So my mapped values will decrease by 1. Otherwise, if I'm including this AI, I'm just checking if still this value count is less than or equals to the number of times it is in B. If it is more than all the values in B, like this AI, like the number of times this AI occurred in B is already like less than the number of times this value is occurring in A subarray. So no value is getting mapped extra. But for this, the values are getting mapped. So hence increasing my number of mapped values. And finally checking the number of mapped values is more than or equals to k. Like I didn't get the question. If the first condition can also be possible if the value, yes, like if this value is not mapped, like, okay, you are saying that, let's say this value was not in B, right? Then this is not possible. Like this will be 0 in that case. And count A cannot be less than 0. Like I'm just removing those values which were earlier here inserted, right? Like for which the count was earlier incremented. So count A for any value won't be less than 0. Is it clear? So this wouldn't work in that case. If let's say some value is in A but not in B. Okay, so let's go to the next
Sir,
problem. Yes.
can you please tell the approximate rating of this question?
Like I don't like this might seem difficult, but believe me, it's like a really simple problem. I would say 1300, 1400. Again, like I might be wrong, but guessing from the number of submissions, plus this is not a very, like, I didn't even think about this, like, quite frankly, I just coded this. That's why it's pretty like messy. And once you get a quite hang of this, like, believe me, problems like this don't require any thinking.
Yes.
Okay, so let's go to the next problem. Like, don't worry. I know like many of you are right now like new to CP. Like very soon you'll be good, like solving these problems very fast. Like these problems are like once you read these problems, you'll just start coding. Like once you are halfway through these problems, believe me, these problems are that typical. So going to this problem. Now in this problem, we are given that a binary string s of length n is given, and a binary string is a string consisting only of characters 0 and 1. Now we can choose an integer k and then apply the following operations any number of times. Choose k characters of the string and invert them. That is, replace all zeros with ones and ones with zeros. Now using these operations, you need to make all the characters equals to this character 1. So then there we are given some examples. We're given the constraints and we need to find the maximum integer k that we can choose such that it's possible for us to do these operations using the chosen k and convert all zeros to 1. So first of all, let's take some examples. Let me share. Why is the screen not being shared? Okay, now it's coming up. Okay, so we have 0, 0, 1, 0, 0. So for k equals to 1, k equals to like 1 can always be an answer. Why? Because we need to select one length subarray, convert these to ones. Just invert them, you'll get 1, 1, 1, 1, 1. Everything is 1. So k equals to 1 is always an answer for every string, for every test case. Now let's look for k equals to 3. So what we can do for k equals to 3, let's select a subarray of size 3, we'll get 1, 1, 0, 0, 0. Invert this, this, and this, right? Then select this, invert these three. So 1, 1, 1. You'll get 1, 1, 1, 1, 1. So k equals to 3 is also an answer because, as I have shown, using the k equals to 3, we can select two substrings. Like we can do these two operations and eventually get each and every character as 1. You can check k equals to 4 and k equals to 5 won't work. So 3 is the answer for this first test case. Is it making sense? Yes, no. Let's look another test case 1, 0, 1, 1, 1, 0, 1. So let's try 4. So 4.
So we have to minimize the number of operations.
Maximize. No, you don't have to. Like number of operations, you don't have to do anything with the number of operations. You just need to find the maximum k. Like for which
Yes.
you can apply some operations and you'll eventually get 1.
Yes.
Like every position will have 1. So let's say this is the subarray, you'll get 1, 1, 0, 0, 0, 0, 1. And then you can select these 4 places and you'll get 1, 1, 1, 1, 1, 1, 1. So 4 is the answer for this. You can see that 5, 6, 7 won't work. So now let's try to solve this. Let's say you had a string and you have a k. How would you solve this problem? Anyone? Like there's a fixed value k, you just need to check whether this k will work or not. Any brute force.
We can we can try to shift all zeros to like one side and then check if it is possible or not.
You will start from one side, either left or right. Let's say I'll start from left. If I get a 0, I have no choice but to invert this. Is it making sense? If I get a 0 here, I have to invert it. There is no other way. So let's say I have k equals to 5. This will become 1, 0, 1, 0, 0. The rest will remain same. Then I'll go to the next place. Again, I get a 0. I have to invert this. Why I'm not inverting backwards? Because I already am making sure that before this, everything is 1. Don't change it. Like don't alter anything before this. It's already perfect. Again, like change this, you get 1, 1, 0, 1, 1, 0. 1, 0, 0, 1, 1, 0. Then again, go to the next place. If you have a 0, you'll have to invert. Nothing can be done. Invert this. you get 1 0 0 1 0 0 0 1 1 0, and there are 2 ones before this. Again, you get a 0. You have to invert. You don't have any other option. 1 1 1 1 1 0 1 1 1, not 1. This will be 0 1 1 0. Then in the next place you have a 1. Don't do anything. You don't have to invert this. But next place has a 0, so you have to invert this. So this will become 1 0 0 1 0 1 0 after this. And before this, everything is 1. So like this, you'll keep doing. Again, you have a 0, invert. So 1 1 1 1 1 1 1 1. This will become 0. This will become 1. This will become 0, and this is 0. Basically, I have inverted these 5 places, and this is what I have. Now this place as a 0, but you cannot apply a k equals to 5 operation here because there are only 4 places left. So at this point, you should have 1 1 1. Otherwise, if you don't have 1 at the last 4 places, the answer for this is no. For k equals to 4, for k equals to 5, you cannot have this converted into, like, you cannot have this converted into something like this. You cannot have 1 at each and every place. Is it making sense? For k equals to 5. So this is how we would have checked. You can say the same thing if you start from the starting, like the ending point, and you can say that, okay, after each I'll come to the left, and I'll make sure that the right of it is having only ones. So this is how we would have done for some value of k. Is it making sense?
Sir, what will be its time complexity?
Like for this, we are just iterating through the complete string once. So big O of n for checking 1k, right? I'm just iterating through the complete string. Like don't worry about what is happening in front. Just check this. If this is a 0, you have to invert this. So let's say somehow you have inverted it. Then come to this and check what is the final value. If it is 1, okay. If this is having 0, invert this. Let's say we are able to invert this in constant time, this part. So then the complete thing is just iterating through these characters. If it is a 0, iterate the next. So now what we can do, if we are able to do this in big O of n, we can, how many different values of k do you have to check? How many different values of k you have to check?
N.
N, basically from 1 to n. So check for each of these, and each is taking n. So n square time complexity, and in the problem we can see that n square is less than or equals to something in order of 10 to the power 6, 25 into 10 to the power 6. So this will work.
Sir?
This will work. But the
Sir?
thing is, yes.
Sorry for interruption, but can you please explain this line? I didn't get this type of lines. It is guaranteed that the sum of the values n square over all test.
Okay. This basically means the number of test cases are 10 to the power 4 and n is less than 5k. So theoretically possible, if this line is not there, then if every test case is having 5 into 10 to the power 5 into 10 to the power 3 as the value of n, then the total value of n over all test cases would be 5 into 10 to the power 7, right? Yes, no. But the thing is, they have already mentioned that n square over all, like in that case, n square over all test cases can be like c.
It means the complexity of the solution will not be multiplied by t, right?
No, let me explain just a moment. See, there are number of test cases are 10 to the power 4 less than n is less than equals to 10 to the power 5 into 10 to the power 3. So theoretically, what can happen if, let's say, that line is not there? N square can be, for each test case, n square can be less than equals to 5 into 25 into 10 to the power 6. Yes? Yes,
Yes,
right?
sir. Yes, sir.
And for each test case, let's say this is the n, then n square for each test case, like n square over all test cases, like the sum of n square for every test case will be this thing. Sum of n square over all test cases would be multiplied by 10 to the power 4. So it would be 25 into 10 to the power 10. But they have clearly mentioned that this is not the case. N square over all test cases summed is less than equals to 25 into 10 to the power 6. This is basically that we can solve this in this problem so that this solution can be accepted for this problem. Otherwise, this big O of n square solution will never work for this problem. So that's why this constraint is there. Is it clear?
Yes, sir.
Now, as we already know that, let's say that we have a way that for any value of k, we can check in big O of n time that whether it's possible or whether it's feasible for us to convert every character in the string into 1 or not. If we can check for any k in big O of n time, then we need to check for n distinct values. So this is n square. But the thing is how to check this in constant, like how to, that thing is okay that we'll iterate. And if let's say while iterating, we find that at any place we have a 0, we need to flip the next or the value, the characters in the subarray starting from this point of size k, we need to flip every character. But how, if we do this, then it will take much more time. But the thing is, we don't actually have to flip anything. What we need to do, we'll say that, okay, we have flipped, because either there will be a 0 or a 1, right? So let's say we have flipped once, and we have flipped once, and till here it is flipped, right? So we just need to mark this position that, okay, just remember that when you come here, you undo the flip. So this is how we can solve this problem. Let's take the original problem. Let's say we had 0 and k was 5. So we need to flip this, right? So flip as 1. We need to flip this, and okay, we have flipped, and remember here that we need to undo the flip. Then come to the next place. So we have already flipped, f is 1. So this is 0, this works. Then we come to this place. This is 1, but f is 1. So this means we have already flipped. So technically this is 0. So this is 0, so we need to flip again. So now you will flip from this place to this place. So remember that you need to undo the flip here, and your flip becomes 0 here. You have flipped twice. So basically from here to here, this part is flipped twice. So this is basically undoing the previous flip. So now you come to this place, you have 1 and flip is 0. Okay. Then you come to this place, you have 1 and flip is 0. Okay. But now when you're leaving this place, you need to undo the flip. So undo the flip basically from 0, you just need to convert this to 1. Basically, if undoing the flip is basically from 0 converted to 1, from 1 converted to 0. So when you come to this place, although you have a 0, but you have a flip of 1. So basically this means that you have a 1 here. And same thing goes for here. That although you have a 0, but your flip is 1. So let me explain how this would have gone if we would actually flipped. So we had 2 0, like we had 0 0 1 1 1 0 0 1 1. So k was 5. So first we would have flipped this. So we would have 1 1 0 0 0 0 0 1 1. Then we would have flipped this thing, right? And eventually everything would have worked. So this is exactly what we have done. See, let me write it here. So here I encountered a 0. So I said I'll flip this much. And I remembered that I need to undo the flip here. So my flip became 1 here. Okay. Basically flipping f equals to 1 means that why you need to undo, because otherwise you are not undoing. That means you complete this complete thing. So I only flipped this part. So only these digits are getting flipped. These are not getting flipped. So if you are making your f equals to 1 here, you need to change your f equals to back to 0 here. So that's why. Now I need to undo my flip here. So this is Then I come to this place. Now, although I have a 0 here, but my flip is 1. So basically this means that this would be 1. So don't do anything. Come to this position. Although you have a 1 here, but your flip is also 1. So this means that flip this. F equals to 1, that means flipping this will give you 0. So since you are getting a 0, you need to flip starting from here again. So if you flip from again here till here, length 5, so your flip here becomes from 1, it will become 0, and you need to undo your flip here. So coming to this, you have a 1 and your flip is 0. And when you leave this point, you'll undo your flip. Basically, undoing your flip means from 0, you'll change it back to 1. Then you'll come to this place, you have a 0 and your flip is 1. You come to this place, you have a 0 and your flip is 1. You undo your flip from 1, you convert it to 0. Then you come to this place, you have a 1 and your flip is 0. You have 1 and your flip is 0. So everything is 1, like this. Basically, if you have character as 1, your flip should be 0. If you have a 0 character, then your flip should be 1. In these cases, it's okay. Otherwise, if you have 1 and your flip is also 1, then you have a 0, so you need to flip at this point. Otherwise, if you have a 0 and your flip is also 0, that is, you don't have flipped. So in this case also, you need to, in both of these cases, you need to flip starting from this point. Is it making sense? Yes, no.
Yes, sure.
What about others? This approach basically works because we are not changing anything that we have already made once in the back. And if we, at the current place, we have a 0, no matter what, we have to flip it. So just flip it starting from this point. Now, the only thing that we are doing smart is we are not completely iterating and flipping each and every. We're just marking the position. Okay, I'm flipping here. And when I go to this place, I'll have in this F that whether the current subarray is flipped or not. And after crossing this point, basically this intersection, I'll undo my flip. That only up till this point, I had flipped my values. So that's why this is working. And for the last, like what you need to do, once you get to the last, let's say I'm doing k is equals to 5. So once you get to the last 4 values, they should be 1. Like basically these two things should satisfy. Either if you have 1, then your flip should be 0. And if you have a 0, your flip should be 1. So let me show you the implementation. So this is the implementation. First I'm taking n as input, then I'm taking string h as input. Initially, my answer is always 1. Why? Because the minimum answer k equals to 1 will always suffice. This is which all positions I need to flip back, like undo my flip. Basically, this is that. I'm starting from k equals to 2 and I'm checking for every value of k. My undo flip like is everything initially 0 and f is basically that thing, whether I have to flip or not. Then I'm iterating from 0 to n minus k because I can only flip starting from these indices. And I'm checking that f plus this is the basically if it is 1 or 0. So f plus this modulo 2, if this is 0, then you need to flip. Basically, this means that if f is 0, this is also 0. If f is 1, this is also 1. So basically, if I have a flip, then the character is 1. If the flip is not there and the character is 0. In both cases, you need to flip. So I'm flipping and I'll undo at this point, I plus k minus 1. Basically, from starting from this point, there is a subarray of size k, which is flipped. So the last index which is getting flipped is I plus k minus 1. So just flip it. And if the current point was undo for any previous subarray, then that will be taken care here. Just take XOR of flip I. If flip I is 1, that means ith point is the ending point of some previous operation, like some subarray. Finally, once I have done this part, I have made sure that the first n minus k places are having 0. But the thing is, what about the last remaining k minus 1 places? I cannot apply operations there because there is no subarray of size k that takes only considers those. It will consider the previous values also and don't want to flip. So technically these should be 1 by now. So just iterate over those values, and this check is basically CHK is that those values are all 1. But in those places, there can be some closing points of flips. So like I have the same logic as this. And finally, if check is 1, make your answer as KY because I'm already iterating in increasing order. So if I get a bigger value of K as a feasible answer, just update your answer and print it. Is that clear? Check and is basically if check becomes 0 once, if this fails once, then it will always be false only. So that's why and. I cannot initialize it. If it fails even once, then it is always false. Like I have a bad habit of like writing everything in one line, but like I should have broken this down. And like when I'm explaining it, like then I'm realizing like I have messed this up. Like this also check and this modulo percentage 2 is equals to 1. Like, and by the way, during like when I was implementing this, I tried to like write code much more clearer. Like first I had written something like this. Then I realized that it would be too much. Basically, this is the same thing. I don't actually have to write equals to 1, right? Just take the modulo and take and. If this is 0, then check would be 0. And like I have a habit, like I was doing some things like this. Out of this, I was negating the value here. So, like these things are also like these things are also okay. Like it's nothing wrong to do like this. It just decreases the readability of your code. If I like usually if I don't have to explain my code, I would do these things. Like I would write this, I would write this like this. And I'm not saying like if I have to explain like I have done a great job. It's still messy. I think there would be like easier ways to implement this.
Sir,
Yes,
this code is this code's time complexity is n square, right?
yes,
For each test case.
yes.
That line in the question, if that line is not written in the question, then we
Then
can't
this
solve
would fail.
this question.
Then this wouldn't work if that line wouldn't be there.
It means for each test case, we can solve this
Basically,
question
this
in
solution is
n
only
square time
when n
complexity.
square is less than like n square over all test cases. The sum of n square over all test cases should be less than should be in range of 10 to the power 6 or 10 to the power 7. Like those number of operations are only allowed in a second. That's why this is working. Otherwise, if data is not there, then we cannot do like this. Then this problem
Sir,
is much harder.
Can you please go to the question?
Yes, yes.
Can you please scroll up? What this thing means? Time limit per test is 3 seconds.
Yes. So basically, there are some test files, right? If you solve this, like if you submit this, then your code will first run off first test, then second test, then third test, right?
Yes, sir.
And in those tests, there would be these test cases. So each test has around 10 to the power 4 test cases.
Okay.
So for each test, like your code should run. For each test, it should take less than 3 seconds. So these complete 2500 10 to the power 6 operations are can happen within 1 second. So that's not the part. But the thing is, if this thing wouldn't be there, then n square solution will take more than a day. So that's why this line is there. Like basically, they are enabling us to submit an n square solution.
Okay. Thank you, sir.
Anything else?
No, sir. Thank you.
Okay. So let's go to the next problem. So the next problem is this. And in this problem, we're given that Elise and Bob gathered in the evening to play an exciting game on a sequence of n integers, and each integer of the sequence doesn't exceed 4. So the rules of the game are too complex to describe. So let's just describe the winning condition that Elise wins if the bitwise XOR of all the number in the sequence is non-zero, otherwise Bob wins. So now the guys invited Eve to act as a judge, and initially Elise and Bob play with n numbers. After one game, Eve removes one of the numbers from the sequence. Then Elise and Bob play with n-1 numbers. Then Eve again removes one number. They play with n-2 numbers, and so on until there are no numbers left. Now Eve seems to think that in such a game, Elise almost wins always. So she wants Bob's to win as many times as possible. And we need to determine the maximum number of times Bob can win against Elise if Eve removes the numbers optimally. So first of all, the whole problem statement is like unnecessarily complicated. Like, see what you are given. You're given 4 integers. This is basically how many times. This is count of 1. How many times you have initially 1. This is count of 2. This is count of 3, and this is count of 4. Now all of these numbers, let's say this is 2, 1, 3, 1. So basically this means 1 is coming twice, 2 is once, 3 is 3, 4 is once. So these are your numbers initially. Now XOR will be taken out of these numbers. We can see that this is XOR is not 0, so Elise wins. Then Eve will remove one of the numbers. Let's say Eve removes this. Again, XOR will be taken. Let's say it is it is again non-zero, so Elise wins. Like this, game will continue, and we need to find what is the maximum number of times Bob will win. Is the problem statement clear?
Yes, sir.
Yes.
Now it's very simple. First of all, if you have a 4, let's say you have 4 odd number of times, can you ever get a XOR as 0?
No,
No,
it is
sir.
not possible.
No, it's not possible. Why? Because 4 XOR odd number of times will result in 4. And using these 1, 2, and 3, you cannot get. Using 1, 2, and 3, you cannot get. You cannot like cancel out the 2 to the power 2th, like this bit. Second bit in 4. 4 in binary is this. 3 in binary is this. 2 in binary is this. 1 in binary is this. So these bits are 0 in 1, 2, and 3. You cannot cancel out this bit. So that's why 4 odd number of times is always going to result in non-zero XOR. So now what Elise can do, Elise can just make this even, and after that what will Elise do? Let's say 4 is coming 6 number of times. So Elise will remove these, like first this, then this. So again, even number of times. So okay, sorry, Eve will remove, not Elise. Eve will remove these 4 even number of times. So XOR 0. Then remove these, then remove this. So same thing can be done for 1 also. Let's say 1 is occurring some number of times. Have it even number of times. So remove this. So 2 is also same. If it comes even number of times, it will become 0. 3 should also come even number of times. So clearly, like the total number of ways in, like the total number of times Bob can win is the number of times this will happen, that Eve will first of all come to a point that this is even, like when count 1 is even, this is even, this is even, this is even. Then remove these 2, then remove these 2, then remove these 2. So how many times this can be done? Count 4 by 2. Then 2 like will be removed here. So count 3 by 2, count 2 by 2, count 1 by 2, and add these. Is it making sense? If let's say 1 was coming, instead of 4, it was coming 5 times, then also count 1 by 2 is valid. Like first of all, she'll just remove this. You don't have to find how many times Elise is winning. Just find how many times Bob is winning. So E will just remove this one, make everything even, and then the number of times divided, like the total number of times this is coming by 2, the total number of times this is coming by 2, total number of times this is coming by 2, total number of times this is coming by 2. There is just one thing now left. That is the case when all of these were coming odd number of times, 1, 2, and 3. This is coming 5 number of times, this is coming 7 number of times, this is coming 3 number of times. In that case, allies don't have to make these 3 even at the start. Allies, because these 3 can cancel out each other. Why? What is XOR of 1, 2, and 3?
0.
Yes. So 4, just remove this 4. Like 4, say 4 doesn't have anything. You have to do count 4 by 2 and like the not like count like this plus count 3 by 2. Like this is still true, but there is, you need to add 1. You need to add 1 in case count 1 is odd, count 2 is odd, count 3 is odd. All of these are odd. Why? Because in that case, at the start only, if let's say 4 is odd or 4 is even, just remove this 4 and Bob will win. Or if 4 is even only, then don't remove that, Bob will win. Other than that, everything is same. Just make this or even, make everything even and remove 2, 2. And for those, number of winning is this. Is it clear? Just one corner case. Okay, so the implementation for this is very simple. Let's take A, B, C, D as input. A is count of 1, B is count of 2, C is count of 3, D is count of 4. Your answer is A by 2 plus B by 2 plus C by 2 plus D by 2. And if all of these are A, B, C are odd, answer is, like, you need to add 1 to your answer. Why? Because 1 XOR 2 XOR 3 XOR is 0. And why I'm taking 1 XOR 2 XOR 3 XOR when they are odd? Like they can be anything, 1, 0, 1, 7, and 3. Because in 1, 0, 1, 100 will cancel out each other. If you have 7 ones, you have 1, 1, 1, 1, 1, 1, 1. So the first 6 will cancel out each other. So if all 1, count of 1, count of 2, and count of 3 all are odd, everything will cancel out. You'll just get 1, 1, 1, 2, and 1, 3. All of these are odd. So that's why these will also cancel out each other. So if 1 XOR 2 XOR 3 XOR is also becoming 0, all these are odd, you need to add 1 to your answer. Finally, print your answer. Is it clear? Yes, no?
Yes, yes.
Okay. So that's it. Thanks for joining. Bye-bye.